We're here to talk a little bit about what is Min Doctor and why I and both of us think it's an awesome place to work. And my name is Cecilia. I'm what's it called, head of technology development. So I have all the developers in my group. And this is...
I'm Flavia. She's my boss.
Yes.
I'm a backend software engineer at Min Doctor. I currently work with Go and a little bit of DevOps. So I'm not just a developer. I also do other stuff and play along with other things. I'm going to show you some of it.
Yep. And we will start off more. Yeah. So we are a digital caregiver. And what is a digital caregiver? We are the largest digital caregiver in Sweden. And it is that we give a diagnosis online, we prescribe medicine, we give referrals. That is, you can go to laboratories and get your test done, and then the doctor can sit anywhere. We have roughly 600 labs that we cooperate with. So it's like we follow all the regulations for a normal primary caregiver. But it's just that it's online, so you don't need to actually physically go to your caregiver. And we have treated 35,000 patients and more up to now, and we're growing fast, both in patients and persons working at Min Doctor. And right now it's only in Sweden, but we will go international next year, so it will be an interesting journey. And when we say we have a new way for patients and healthcare to connect, of course it's the same doctor and it's the same things they know and how they treat patients. It's just how you make the journey from where you feel ill in your throat to actually get your prescription, or if the doctor say it's enough that you go home and rest. So we think, or we believe, that better availability will than today's primary care will help solving the problem that it's so cramped and it's not easy to get a time spot at the primary care. But letting some of the cases go to digital care units like Min Doctor, Cree, Visible, will free up time on the physical places as well. That will then make the treatment better for everyone, not only the ones that use Min Doctor, but also the ones that still in the hospitals. And we have all development done in Malmö, which is luxury, I think, because we have everything in the same house. So you have great chance to influence everything, or whatever you feel like. We are roughly 60 persons. We have a PR, marketing department, we have a design department, we have a product department, we have development, design, development, and we also have doctors and midwives and quality assurance employed at the head office. But most of the doctors actually work full-time at another place. So they work at their hospital or another primary care unit, and they do this in their extra time. Or if they are on vacation, because you can be located everywhere. That's a good thing about it. So you can be on vacation in Thailand for 4 weeks as a doctor, and you feel like, it's kind of boring to be with my family. I will treat some of the patients. And that's why it's also working to have it open 24/7. Because doctors works mysterious ways and mysterious hours. They work sometimes nights and have days off, and the other way around. So anytime you can reach Min Doctor for getting help. I think that was it. Also, why I think it's a really, for me personally, really nice place to work is that I think this actually makes a huge difference in everyday life in Sweden. I worked a long time, 20 years or so, and mostly with making things like everybody does. But there are already so many products of anything. It's kind of hard to make up the product that changed something. And I think here we have a luxury to be able to influence how the primary care later on will be done in Sweden and in Europe and the rest of the world. So we want to become your first point of the contact for healthcare. And how? It is to make the journey for the patient towards a doctor better than it is today. Because today it's a lot of... I think the healthcare system in Sweden is really good. I mean, the doctors are really... They know a lot and they treat you very good, but it's so many levels that you have to kind of go through, and the information gets lost on the way. And here you have the possibility to, as a patient, send in your stuff when you feel that you have time to do it. And it's asynchronous, so you don't need to look nice when you go to the doctor or something. You can just fill in your information, and many people like me, when you get stressed, you forget half of the things. And now you sit by yourself and you don't forget, because then you just look through your stuff again and you can do it again. And I think everyone working at Min Doctor are sure that this is the way it's going to be done. And of course, we want to be part of it. And right now, we're the biggest one. You never know. Competition is good, and you always need to improve to stay ahead. That's our goal. And as I said, it's a cross-functional company. And we have doctors and midwives and supports and PRs. And for developers and designs, we work closely. And almost every day you have interaction with them. For me, there's also a change from where I worked before. That has been more engineering-centric companies. So I mostly work with engineers. So here I think it's a good mix from different competences, which makes a product better, I think, when you have many various influencers. We have startup mentality. It's about making a difference. You have to have courage to try and fail, and it's good to fail. You're supposed to. Otherwise, I think you spend too much time making it perfect for the first time. It's just you need to release often, and that is what Flavia is going to speak later on. And it has to be, you need to know where you're allowed to have the errors and where you're not. Since it's medical data, of course, we cannot ever have an error in the medical data that you provide to doctors. But I mean, you could still have other errors that doesn't influence the medical parts. And it's not errors in that sense as well, it's that you need to try things. You need to try and release often and see, oh, was this liked or was it not working at all? If not, then don't spend more time on it. Just move on to try to do the new things. I think it's flexible, and it's more about engagement than keeping track of each minute or hour or the roles we have at the company. It's about just do it, like the Pink program said. It's more try it and do it. And that's a mentality we like. We're trying to be a learning culture. We have to move fast and efficient. And we have to try things. We have to push out things for user, both for patients and doctors, that we're not 100% sure are perfect or not the way they want it. But then we can just try another thing if it doesn't work. And we are in dev tech 4 small teams. It's 15 developers, split up in 4 teams. We're trying to have them cross-functional from design all down to the backenders. And I think it's a lot of autonomy. It's up to the teams on how they want to do things. Of course, there are some rules, but it's less than in many other places, I think. Not everyone are the same. You need to try to bring out the best of each person in an organization. It's about who you are more than what you actually have been doing before and what you want to do and accomplish. We have, as many others, innovation and FedEx days. I do think it's an excellent idea. And for those who don't know, FedEx comes from in 24 hours you deliver. So you get one day that you can do whatever you want. And then in the end of the day, you show what you have accomplished. And then you can, of course, make themes. So you can say that this is what we want to bring Min Doctor forward to. And Google Time is more, the term comes from that you're kind of allowed to do what you want. We have it once every other Friday. So, of course, do what you want does not really include going out eating an ice cream. But do anything you want that you think will improve your work situation, or you want to learn some new things. It's very flexible. And I think that's how you get engagement. And that's how every company will get a better product, I think. And we're growing fast, both in the patients, like all startups, we want this hockey stick. And we have a hockey stick, kind of. And it's about balancing the structure of when you grow. Both structure and freedom doesn't really need to be fighting each other. It can go side by side, I think. But I think that's a challenge we have going forward, because I think that's how you keep engagement. Also, when we're growing fast, we need to scale the service. Yes. And there we go over to Flavia that will show how cool stuff we do to scale it.
So Min Doctor is all about making people's lives easier, right? not only on the patient and doctor side, but also on the development side. I think we try to make our own lives as easy as we can, and that's where all the automation comes to play. These are some of the technologies that we use and love. React, Native, Git, Kubernetes, Postgres, Go is the cutest one, the Gopher. Angular, JS, and Docker. There's probably more not so important. They aren't listed here. Just Gophers because they're cute. All the presentations need something cute. No, I'm just going to tell you what I love about Go. And this was the second thing that made me apply for a job at MinDoctor, that they use Go. Go is super fast as a compiled language, so it has all the benefits from compiled languages, but it feels like a dynamic language because it's super fast to compile, it's not so hard to learn. It has a super intelligent and easy to use concurrency model. How many of you have used Go or heard of it? Go, the language, yeah, heard of it, and used it. Okay, so I'm going to show you a small program that hopefully will give you some, I don't know, it will raise your curiosity a little bit about Go. And if nothing that I tell you convinces you to try Go, just look at the Gophers. And Docker is a containerization solution, is an abstraction on containers. How many of you have used containers? Cool. Have you used Docker? Yes? Yes. So you probably know that there are many other container abstractions out there. Some other names are Rocket or LXC or LXD. But Docker is definitely the most well-known one and the most well-supported one. If you go to AWS or Google Cloud Platform, for instance, both of them, they're big players on the cloud computing market, and they have built-in support for Docker, so you can deploy your program there in a Docker image. So it's really straightforward to move to Docker. You have to be a little bit careful if you have, for instance, like a big monolithic app that you built. It's all in one, and you have one API, and the external API is together with the internal API, and their configuration is messy. So if you're going to just jump into Docker, be careful. Not everything is flowers and heavenly. So without going much further, I got a bossy gopher asking some code, and let's give it some code. So I have a very simple example. I showed this on another presentation, but I have way less time here, so I'm just gonna be super fast and feed you a lot of information, and I can speak really fast. So please, I don't know, grab me in the corridor if you want to hear more about it. Let's look at our programs. So Go is like any other compiled language. It starts with a main package or program, the main entry point. Different than Python, for instance, if you come from this word. And there is a very simple program. It's a web server. And I'm just going to show you the code of the web server itself. It's a function, and it follows an interface by receiving two parameters, response writer and response request. One thing I want you to notice here is that the response writer has a different naming convention from HTTP request. Writer feels like a doer, writer, and request is just a thing. So Go has this super powerful concept of interfaces, and they work very differently from other languages' implementations of interface. One example is that you don't have to explicitly implement an interface. Interfaces in Go are implicit, and that gives you a lot of flexibility. And the other thing is that you can pass them around as arguments. So here I'm saying that my hello world function receives a response writer, which is an interface type. And that's odd, isn't it? It's weird. Why am I giving an interface type? And that means that I can give this function any object that responds to the response writer interface. And that makes it really easy to test. I'm going to show you the one test that I have for this, but not now. Let's move further. So here I just get the host name of my machine, and then another thing I want you to notice on this program is the error handling in Go. It's returned. I return the error instead of throwing an exception. So this is also very different from other languages. And some of you made weird faces by looking at it, and I also did. When I saw this, I was like, what? I have to pass my errors all the way around and I have to check them? But this is actually much more simple than in other languages, I would say. And the simpler, the better. Can I say it? Simpler? It works, right? And this is very simple. It's very, very, very straightforward. So the error handling and the decision about the error, you make it right after you call the function. I think it makes your program a little bit bigger because you have to check every time if a function has an error, but you have to make the decision right there. And then if there is an error, I decided to give an error back to the user. So I just print, oh my gosh, I had an error. And then I stop, I return. If there is not an error, I go forward and format the body of my response. And then I print it to my response writer. So then it's just boilerplate here. I call HTTP handle func, giving it the path and the function. And another thing to notice here is that functions are first-class objects in Go. So you can give a function as a parameter. Mind-blowing. And then I listen and serve my program on port 4000. So now let's open the tests. I really have no time at all to say it. I'm just going to show you that here is my response writer, and it's another, I'm getting it from HTTP test, which is a helper module, and then I just give it. And as it is a recorder, it's recording everything that I'm doing in the handler to help me test it. And the test that I do here is very simple, very silly. I just assert that the status code returned from my handler is 200, as I'm expecting. So to show you that this works, I run the tests, and there is nothing wrong with it. And then I'm going to run my program. And even though Go is a compiled language, I can just call go run. And this is going to compile and build and run my program for me. So let's see if this actually works. Yes. So as you see, I printed my host name, which is Cylon. And now I'm going to run this on a container. So as you can see, I have a Docker file here. I'm not going to show you right now that because I have like 1 minute left. But let's build this. So I invoke docker build, and -t is the tag that I want for my image. I'm going to call this hello, and I'm going to give it a version because that's good practice. And I'm going to say that the Docker file, which specifies how to build my image, is on the same directory that I am right now, which is dot. Oh, I forgot. So I have an add hello here, and this is the binary for my application. So I forgot to build this binary before I just ran with go run. So there is no binary. And if I do only this, it's going to build my program for my own platform, which is Mac, and the container runs on Linux. And I want to build this for Linux. So that's another very powerful thing about Go. I can just tell it the platform you want, and it will cross-compile it for me. Now, it takes a little more when I'm cross-compiling because, it's extra work. So just to prove it that it won't run on my machine, there you go. So now let's build it again, now that we have what we need done. So if I go docker run --rm, which is remove this container after I kill this command, and the ports 4000 on my host, 4000 on my container, and my image is hello, v01, right? Yes. And 20, hopefully. And if I come here again, then it changed my host name. So I'm running in a container now. And I don't really have time, but if I wanted to run this on Kubernetes, this would be really easy. I would just have to push my image and move it there. So hopefully I give you an impression that doing things with Go and Docker and even if you want to go further to Kubernetes, there's not much at all. And I hope you are now curious about Go, and maybe we'll go to play.golang.org and try it out, because you can write it on the web. That's what I had to show you.